All right, good day, guys. Today I wanted to discuss a vectors multiple choice question that a lot of students have been sending to me. So I thought the best way to take care of this is just to make a video on this one. I'll try not to keep it long. So for those of who have been doing their multiple choice maths questions, I'm sure at some point in time you came across this particular question where they gave you a parallelogram. Okay, now just to recap, the opposite sides of a parallelogram have the same length and they are also parallel, which means these two are parallel and have the same length, and these two are also parallel and have the same length. Just to clarify, what the question had asked the students to do was find the vector XA. So XA means you're standing at X and you are trying to go towards A. While this question is a simple question, the choices laid out between A, B, and C and D were not as clear-cut as it seems. They also said in the question that A was the midpoint, which is very, very, very important in the question. So A is the midpoint of this line. So let's go through a few different possible answers, and with all of them being correct. First of all, what you need to know is that parallel vectors that have the same length have the same value. So if two vectors are parallel and have the same length, that means they have the same value. So let's explore one possible answer here. How can we walk? Let's say we have this helicopter here and we want to go from X to A. There are many different ways we can go from X to A. We can fly along this line here, but usually in vectors, you're not allowed to go along the easiest path. So what's another way we can go from X to A? Well, we can go from X to W, W to Z, and Z to A. That would definitely take us from X to A. What's another way we can fly from X to A? We can simply go from X to Y and Y to A. All right. And now before I want to explore the first answer, let's go the long way and see what answer we will come up with. So let me just take a small break here and just explain something. If I have a helicopter on this line here, QP, this vector, and let's say the pilot, flew from Q to P. Notice the direction. Direction is very important in vectors. And we asked the pilot, right? Sorry, a better marker here. We asked the pilot, hey, what's the name of the vector you just flew? Remember, he just went from Q to P. So the pilot could respond, hey, I just flew from Q to P. So that's the vector, QP. The first letter is where you start. The second letter is where you end up. So he told the truth. But did you all know that whenever you put a minus sign in front of a vector, that means you are going the opposite way? So here's another response the pilot could have said. Remember, he just flew from Q to P. So if he said he flew from P to Q, would he be correct? No, because QP is this way. But if he said he flew minus PQ, he would still be telling the truth, because PQ is this way. But notice the minus sign, which means he is indicating he flew the other way. So whenever you put a minus sign in front of a vector, it's that vector, but the opposite way. So that means if he said he flew QP or minus PQ, both answers would be truthful. All right? So I just wanted to recap that. Also, if I put an X here and I called it M, and M was the midpoint of that line, did you all know that if the pilot flew from Q to M and we asked him, hey, what did you just fly? Well, he flew from Q to M, so he went along the vector Q to M. But QM is half of PQ in this direction. So if he said half of PQ, direction is very important, this would be wrong, you know, because he is flying from Q to P. So he would have to say a half Q P. And that answer would be just as correct as Q M. If he said he flew half of PQ, would he be correct? No, because PQ is this direction. So for him to be correct, he would have to put in a minus sign, because half of PQ with a minus sign means you are going the opposite way. And keep in mind, this vector and this vector in this direction is the same exact vector, because if M is the midpoint, here and here have the same exact length, and of course the two lines are obviously going the same direction, which means they are parallel. Okay, great. So let's go back to this question, and don't worry, I'll be talking about these things that I just said over and over. All right. I know it's a lengthy explanation. I thought I was going to keep it short, but I want to make sure everyone gets the theory down properly, so in case they twist the question in the exam, you know how to think it through. So XE, let's find a potential answer for XE. To go from X to E, you can go from X to W. Direction is very important. X to W. Once you reach to W, you can go from W to Z. So plus W to Z, plus from Z to E. Right. But obviously Z to E is not going to be on the multiple choice answer. Remember, if A is the midpoint, that means ZA is half of ZY in this direction. So if I erase the ZA and put half of ZY, that would be a potential correct answer for this question. Okay, I'm just going to play up with it a little bit here. You notice when I said we went from X, when we're going from X to A, the first part was from X to W. Look, I have it here. X to W. Here's another potential answer. I could erase XW and put minus WX, and it would still be correct. I know WX is this way, but I have a minus sign, which means I'm already indicating I'm going that way. It's just a difficult way of saying the same thing. But this answer is also correct. Instead of saying WZ, I could say ZW, but put a minus sign. ZW with a minus sign really means I'm going the opposite way. So you see, there are many different correct answers that can appear in the multiple choice, but this wasn't the answer they had put. We're going to take the short way now and develop another answer. XA. What's another potential answer for XA? I can go from X to Y in that direction. When I reach Y, it's time for me to go from Y to A. So plus from Y to A. Obviously, Y to A is what? Y to A is half. Remember, we're going this way. So if we're going from Y to Z, Y to A is half that distance. So I can erase the YA and put a half of YZ. And that is a potentially correct answer. But I just want to point out that not even this was the answer stated in the multiple choice, even though this is a potentially correct answer. Here's the answer you may have seen between A, B, C, and D. Instead of putting XY, we'll put the XA here. Instead of putting XY, didn't I mention at the beginning of the video, WZ and XZ, since it's a parallelogram, they have the same length and they are also parallel. So that means WZ and XY are the same exact vector. So instead of putting XY, they put WZ. So this vector is also WZ. And what they did, instead of going from Y to A, so instead of going from Y to Z and taking half of that value, they went from Z to Y and took half of that value. But remember, we're trying to go this way, X to Y and Y to A. So let me write the answer first. Minus a half ZY. Let me explain why this and this is the same exact thing, right? These two things are the same exact thing. ZY is this way, and I put a minus sign indicating that I'm going this way and only half the direction. Okay, so this was the answer that was stated in the multiple choice. So I cannot understand why a lot of students had a lot of problems, I guess, comprehending the question. Okay, guys, so I really hope that this was helpful. And, well, there's a storm coming tonight, so I guess I'm going to have a lot of free time. So look out for more videos tonight. Take care, guys. Alright, guys. So here's another question that a lot of students have been messaging me about. It's a probability type of question. So let me give you the overall plot of the question. They said that you had a dartboard that you think you throw darts at, right? And well, the dartboard is a circle and there's a little area they call the bullseye area. So they said in the question that a person who is throwing the darts at the dartboard has an equal chance of hitting anywhere on the dartboard, and that the person never misses the entire dartboard. So that means every time the person throws, he's sure to hit the dartboard. He never misses. And where the dart hits is equally likely at any point on the dartboard. So the area of the end, the radius of the entire dartboard was 8 centimeters and the bullseye area was 4 centimeters. They want to know what's the probability of hitting the bullseye area. That's the colored area, the pink area. So they want to know, when you throw it, what's the probability that it hits within this circle. So believe it or not, this is really an areas question in disguise. This here is the formula that I used to convey the understanding of the formula for probability. Probability, at the end of the day, it boils down to this: what you care about divided by the total. I know that's not the official formula that you'll find in the textbooks, but it will help you understand it. What do you care about? You care about hitting things in this area, which means we are going to find the area of the pink region and then divide it by the total of the entire dartboard. That is what it boils down to. Now, one of the answers in the multiple choice is a half. And of course, it's there to trick the student, because they see 4 and 8. And of course, 4 divided by 8 is a half. So a lot of students, without thinking too much, they would just put a half. But that's not the actual answer. And I'm going to prove it to you. Let's find the area of the pink region. Remember, you don't have a calculator. So the area of a circle, the pink region, is pi multiplied by the radius squared. What's the radius of the bullseye region? 4. So it's 4 squared. And what's the area of the entire circle? Pi multiplied by, and the radius of the entire circle, the whole dartboard, is 8 squared. So let's see what's going to happen here. Right? Just making sure nothing's falling off the camera. Nope, we're good. So the pi and the pi will automatically cancel out. 4 squared is 16 and 8 squared is 64. If we simplify this fraction, 16 into 16 is 1 and 16 can go into 64 4 times. So the actual probability was a quarter, not a half. Okay guys, so I hope that cleared up the explanation for that question. At least 20 people messaged me with this same exact question. Okay, so I have a good feeling, I just have a feeling that this question is going to come this year in the 2020 maths multiple choice exam. That's just my feeling. All right, so question 3. Here's another question that not as much as 20 people asked me like in the last one. I think it's about 5 or 6 people only. They wanted to know the ratio of the triangle to the entire rectangle. All right, so and they gave you no values in this. So this is how you go about a question like this. You choose your own values, and you notice these lines here means that this length and this length is the same. So this is kind of like a midpoint, and this length and this length is the same. So here's like the midpoint of the entire line. So here's what we're going to do. We're just going to choose random lengths, and believe me, anything you choose will give you the same answer at the end of the day. But choose easy numbers. I'm going to choose the length of this side here to be 2 centimeters, and I'm going to choose from here to here. Let's assume it's 4 centimeters. Like I said, anything you choose will give you the same ratio at the end of the day. This means if I choose this, I can find the area of the entire rectangle, length by breadth. So the rectangle is easy. 4 by 2 is 8. So the area of the rectangle is 8 centimeters squared. But what about the triangle? If here's 4, then this length is also 4, which means here's 2 and here's 2 to give me a total of 4. But I'm only concerned about from here to here. So that means from here to here is 2. If here's 2, then from here to here is also 2. And this is half, or the midpoint. So from here to here is 1. How do you find the area of a triangle? It's base by height divided by 2. The base is 2. The height is 1. And we have to divide it by 2. So 2 by 1 is 2. Divided by 2 is 1. So that means the area of the rectangle is 1. So the ratio is 1 to 8. Or if they ask you to express it as a fraction, it's 1/8. Really, really simple. And if you are choosing anything else, like if you chose here was 8 and here was 16, you would have gotten the same ratio. But let's test run that to see if you would have actually gotten the same answer if we had chosen different numbers. Okay, let's choose here as 10, right? And let's choose here as 40. Bigger numbers, and let's see what we got. Well, that means the area of the rectangle is length by breadth, which is what? 40 by 10, which is 400. We can do that in our head. Let's try the triangle now. If here's 40, then below here is 40, which means from here to here is half. So here's 20. If here's 10, since this is the midpoint, this is 5. So base is 20. Height is 5 for the triangle divided by 2. 20 by 5 is 100. 100 divided by 2 is 50. So 50 divided by 400 is 1/8. Same answer, guys. Okay, so I hope that cleared up that question.